from UT Austin.
You want me to just start or wait?
Yeah,
for more
just wait.
people coming
Yeah,
in?
probably wait a little bit. Let me check the online here. Yeah,
I can start. Okay. This- Y'all hear me? Great. All right. So my name is Connor. I'm a PhD candidate at UT Austin. I am very nervous to be here, but I'm happy y'all are here. I want to talk about Community Canvas. I've been thinking about this sort of web app for a few years now. I look at public participation and the way technology can affect it in urban planning. So this is sort of a culmination of a few years of thought and work, all put out in front of y'all smart people today. Perfect. So I don't need to spend a lot of time here. I think most folks have heard about participation gaps and challenges with unequal participation rates. It's tough to get folks all in the same room, all together with varying schedules, varying abilities to participate, so on and so forth. I took this picture and then it turned it into a sketch of a man who was trying to explain why he wanted multifamily housing in his neighborhood. The city council was not particularly interested in it, but you can actually like see the anguish in his face of he was being priced out, and this would be a way to stay in his neighborhood, but he didn't have the ability to sort of like explain how it would look or why it could be beneficial to the neighborhood. He didn't have the sort of technical knowledge that many planners have, and you face people in suits on the other side that have been paid a lot of money to say why this shouldn't come in. That power imbalance really was sort of what got me thinking about the ability that generative AI can help. I propose Community Canvas. It's a mixture of generative AI technologies, conversational, generative visualizations, dynamic knowledge integration, and then all built around this trust-centered design. So I started off looking at artificial intelligence and ethics and the ability and the ways in which people trust these sort of systems. So that's really sort of baked in from the beginning of my thought process. This is what it looks like. It's actually up and running right now, collecting data. So I don't have a lot of results to share with y'all today, but I'm hoping actually y'all can participate and become part of my data set. But this is what it looks like. That chat mode in the center is powered by Claude Sonnet right now. I experimented with a few fine-tuned models. A generative or a general model ended up working better. I'll go into that later on this week, actually, in another presentation. But the left side shows city planning priorities. This is all not an actual place. Research-wise and feasibility, it didn't work out with an actual city and an actual park redesign. But those are sort of like standardized ideas of what a city might actually have priorities for in a park. And then you can see the right side, the original image and generated images as you go on talking to the LLM. So the way it sort of works is someone will present an idea, a facilitator model, in this case, Sonnet 4, will extract features from a conversation. So if somebody says, I want park benches and some shade, those sorts of keywords will be extracted from a conversation. Then a feasibility layer will come in that looks at things like why would you possibly want a cafe in the middle of a downtown intersection or something like that. So there's a feasibility check there too. The model weights the conversation based on recency as well as feasibility. It then creates and generates a prompt that would be optimized for stable diffusion, the image generation model in this instance that I'm using, the turbo model. The the image gets created based on the prompt. It gets passed back to the user. The user can then modify the image, can say, I don't particularly like that color of bench, or that tree, or that canopy doesn't really make sense here. The model can view the image, it can take that feedback and then create another cycle. So basically it's a loop until someone is happy with the eventual sort of notes about the conversation, the image, etc. It all gets bundled and packaged and put into the back end where I can look at it. Of course, all anonymized and everything. There's several sort of parts of this that haven't been completely implemented yet, like the standard retrieval. Looking like at a RAG pipeline to sort of build in more technical components like ADA compliance, whatever a city may have in terms of what they want their park to look like or their downtown intersection. Things like crosswalks have to be a certain width, or curb lengths have to be a specific cutout type, etc. So that will be in a version 2 of this work. But for now, it's, as I said, I built in Hoff and Bashir's trust framework. This looked at trust and automation originally, but I've been applying it to AI, where the layer 1 is dispositional trust, how a user automatically thinks about AI when they're going into this sort of situation. Layer 2 is situational, things like task complexity, the control features you have within a platform, transparency, making sure that everything that's generated is clearly attributed to artificial intelligence or the generative model. And then learn trust, the time it takes as you use a cycle to sort of feel better and better about it as you interact more. Feedback on the performance of the model, how many times it spits out something that you don't think is correct, how many times it listens to you, how often it hallucinates, etc. All of that is getting measured in pre and post surveys, as well as sort of implementation tags in the platform. The biggest sort of challenges I think I've faced here, and I mean, I'm sure with the amount of brain power in this room, there's 100 ways to improve this immediately, but I'm a solo PhD student who's sort of coding this all by myself. But multiple input modalities is what I'm most interested in working on. We've seen this sort of in previous presentations with different languages. That's something that AI, I believe, can help with. The way to actually generate images and remix images, I'm interested in. The ability to drag and drop like predefined elements that a city may believe is very important to have into the different images. And really sort of pushing the idea that these images and these packages of data are starting points and not sort of complete solutions. I think that's sort of where I have been hung up the most. I want the idea of co-intelligence or symbiotic planning in this instance to sort of be the paramount part of it that apologies is anyway, starting points, not complete solutions. I will evaluate the framework. Basically, I'm looking at the effectiveness of human AI co-creation and then the implementation challenges and opportunities. I have a lot of platform analytics I'm collecting when folks use Community Canvas. I have survey instruments, and then I have the content analysis side. So I will generate a wealth of data to look at over the next year or so, hopefully. Benefits, clearly, it's relatively inexpensive to use these models. I can fund this research myself, which is incredible on a PhD student salary. It's cheap. Real-time visualization, this sort of, the process can take as little as a few minutes. Like a conversation and an image can be generated in a minute or so. I can cut that time down even faster with different models. Multiple modalities, I hope, will lower the participation barrier. I love the idea that someone could get buzzed on their phone as they're walking by a park, say, hey, this park is getting redesigned. Do you want to give some community input? Take a picture. add some things, see what you want, and I'll have it sent off and packaged in a few minutes. I think that's fantastic. As you can see, plenty of limitations and plenty more work to put into it. But I think the sort of main takeaway here is that I really want you to look at is that Community Canvas explores how AI can enhance rather than replace human participation in planning processes. Thank you. And I forgot to mention the most sort of, if you'd like to participate in the study and give more thoughts on the data set, it's ourcanvas.org is the URL. It's up, it's running. You can create an account and contribute to my dissertation work. Thank you.
So for this session, I also want to kind of prioritize our online participants to invite them ask a question. So if any question from online, you can just open mic and ask. No? Okay, probably you're gonna have, yeah.
Connor, nice work. I think that this kind of community visioning application is one of the most exciting applications of generative AI in my mind. I have a question for you. When the image is generated, you mentioned that the user can do another prompt to then change what gets generated. Have you considered using something like a segmentation model, like segment anything, let a user draw on the picture to identify an ontological object, and then specifically try to change that thing?
Yeah, I would say my list of sort of added features and things I want to build in is so long, it makes me nauseous to even look at this point. So yes, I have considered it. It's just truly a feasibility thing right now of I am self-taught on coding and figuring this all out. So yeah, purely feasibility.
So where have you implemented this, or have you utilized it somewhere to generate some of your data right now? What projects have you utilized this in?
So right now everything is theoretical. I mean, it's not about any particular location. The idea of public participation, I think, is and like a park redesign or a street intersection is relatively universal. I would love to eventually be able to implement it in a real sort of world scenario, but everything is theoretical right now.
Okay.
Thank you very much.
Next, we have Dr. Shengxiao Li from National University of Sino. Yes.
Right. Good morning, everyone. And today I will share some of the work I do with my student Tian Lelo, Nick Kling from Cornell, and Yubing Liang from Tsinghua in China. So in this work, what we're trying to do is that we try to just classify the transportation decarbonization policies. So that is Nick and I just get awarded a very small grant from NUS and Cornell. So, but we just plan to do something a little bit ambitious. So what we want to do is that we want to compare, contrast the transportation decarbonization policies across the global cities, but we get stuck at the first step. So basically what we want to do is that we want to just collect all the text information in the climate action plans and think about how to just get them into a policy data set. So for example, we have the sentences like California will have all the vehicle sales electric by 2030, but that's not comparable to something that Amsterdam did, right? So we want to have a data set that has two levels. So the first is policy area. So what the policy really talks about is active travel or electric vehicles. And then it's the detailed policies, but it's not nuanced towards something like 2030 or specific numbers. So we want to have an intermediate level of the policy, for example, to just get more excluded bicycle lanes or something like that. So, and then the next step, what we want to do is just to compare and contrast the different policy priorities of different cities. But we stuck here when we do the human coding is because when we do the human coding, we found it's very complex and is out of our capacity to do. So basically, that is, when we do that, we need to just go back and forth to think about what's this sentence talking about and get that into the detailed policies, and then to think about the areas. And we need to think about what's the optimal numbers of the policies areas there are, right? It's not too many, not too few as well. And also another barrier for us, because both Nick and I focus a lot of studies in the United States, we don't really understand much about Europe, and especially in the global South. So basically, the diverse culture backgrounds just prevent us from just doing further work. And also, that is the human coding process have a lot of limitations in terms of the consistency of applying the codes and also the memory of that. So basically, we tried several methods, especially in the machine learning. We talked about in the last session, especially the topic modeling, but it does not really have the good results because the different documents really have nuanced differences. So basically, we go to ChatGPT. Before this week, I'm not a believer of ChatGPT, but now I believe it is really, really powerful. So basically, that is the current work has a lot of applications, but is not many from the planners actually. So basically, there are the computer scientists, political scientists, who classify the policy documents and sentences to the very broad categories. So for example, they might just classify several millions of documents to very simple categories. Economy development, I think, is a misuse of that. And also the qualitative scholars actually have applied many of the methods to annotate and code the different sentences. Actually, is very powerful. And there are several ways to just evaluate the similarity of the text based on the current methods. And finally, actually, there are a lot of techniques, for example, the prompt engineering, fine-tuning methods to just think about how to just improve the performance of generative AI. But what is our contribution? I think is the current work does not really apply to our context for several reasons. So the current work tend to just get very simple categories based on a very huge sample, but we try to do something different. So we have a relatively small sample of the documents, but we want to get rich information at the two levels of the policies. And second, the current studies does not really classify into two levels, like what I said. And also, it's really rare to see a multinational nation example. So we want to see that how well ChatGPT can apply to a multi-culture context. And finally, like what we discussed before, that is maybe if we just input the codes from the different cities, different contexts, maybe we will get different results. So we want to try that. How does the city level variations of prompt engineering can influence the results? So the data for this sample just comes from the C40 cities. So we just find the climate action plans that are available in the C40 cities. So C40 city is a climate action network. So it actually has more than 40 cities. But in this study, we selected 42, which has climate action plans. And then we just selected all the sentences related to transportation in the climate action plan and used the human coding. We did not finish that yet, and ChatGPT. So when it goes to ChatGPT, we thought about two different logics to do the coding. So first is bottom up, is that we want to just classify the different sentences into the different policies, the intermediate level, like I said, and then the next step is to get into different areas. But another logic is a little bit different, it's top down. So we want to just get to different areas first and then get into different categories. So for both of them, we just categorize them using the k-means methods. So the k-means is just relied on the embedding model of ChatGPT-3. So, and then that is the model for the zero shots. That is, there is no examples provided for them. So we just try the few shots as well. The few shots is just you provide some examples for each sentence, what kind of intermediate policy you will give them. So for the few shots, we just tried the different methods. For example, if we just select one city from Africa, Asia, Europe, North America, or if we get a mixture of the cities, how the results will differ. So, all right, so it's a PDF. I think I'm the one who did not follow the rules. So basically, the results was just blocked here. It just shows the differences between the top-down and bottom-up, how they just differ from each other. So basically, the top-down methods, because it will get the optimal numbers of the categories first, it gets more categories than the bottom up. But for the intermediate policies, I get the results that are super robust in terms of the zero shot and few shots. So we also just compare to the similarities in terms of the text in the different scenarios. So as you can tell here, the reference category is bottom up, zero shot. Basically for the different categories and different intermediate policy level, so the consistency level is about 0.7 to 0.8. So based on the current literature, it is relatively high number. But I want to show some differences, very preliminary, about how that might be different. So this just to show the results for I think this is bottom up. So as you can tell, that is the size of the text just shows the prevalence of the topics. And here you can see that really highlights public transit and cycling. But if you use another method, the electric vehicle really stands out. So I think that really shows the very big picture of how the different coding methods might just differ for classification. So to sum up, it really shows that OpenAI has really great potential to classify the transportation decarbonization policies like this project. So it differs from the previous research in terms of those just classifying the general plans, right? So which give a more specific results. And also that also shows how the different prompt engineering methods might yield the different results. So the next step, we will do the human coding and see that how the generative AI is different from the human coding. That is all for today. Thank you.
So again, any questions from online participants? Chat? Yeah. Okay, how about people inside? Yes.
So very interesting work. So I wondered if for the different method you use, you mentioned that if you want to study the global sample, you want to do all kinds of samples, they will write these policy documents. So first of all, in your method vary for different for countries in different countries. Secondly, your results versus significantly different. I know it's still working both ways.
So not really. So what we did is that we put all the sentences from the different documents together. as a data set. So the analysis on the samples here, there is a column shows that is where the city it belongs to in terms of the climate plan. But basically, we just put all the sentences together so that to provide that learning sample. But the sample is pretty small. There are only about 2,500 something for the sentences in as the sample.
Basically, your method do not count for the different context, variation, possible variation, but in different countries, the process of developing this policy documents could be different.
Yes.
Priorities, but you basically apply kind of the same method to evaluate all these documents together, right?
Yes, just extract all the sentences and put in the same context. And we hope OpenAI can understand that.
So I have a question about using natural language processing on policy documents. This is the toughest question I have, and so the audience knows, full disclosure, you were my PhD student, and I've shown no favoritism. I'm gonna ask you the toughest question, which is, what good is this? In the sense that these are plans, these are intentions, these are aspirations. Do not we also need to know which of these approaches were pursued and how well they worked or didn't work before we are able to say, this is a good approach and a bad approach? And if that's the case, how do we think about incorporating that information?
Yeah, that's a good question. I think that's the next step we want to do. So both Nick and I think generative AI really just give us a pattern about what the city did, but not really about the motivations or implementation of the policies. So the purpose of this study is really just like an overview of transportation decarbonization policies across the different cities that is comparable.
Yeah, I have a question. So that is a really interesting research. But one of the very well-known limitation of ARM is its hallucination, that it will confidently make some mistakes when they classify this policy document. So I have a question in that when you let the ARM to classify this transportation-related document, will they happen the same question? Because I have tried it before, I found that when the ARM classify this transportation expertise terms, they will make a lot of mistakes. For example, like accessibility, their definition of accessibility is totally different as in the transportation domain. So I want to ask if that happened in your research.
Yeah, that's a good question. So we just try to look at the literature and try to learn how to write the prompt. So fortunately, that works well. So our first sentence in the prompt is that assume you are a transportation policy analyst. So if you put that in the context, so actually accessibility, they understand really well. Mobility, they understand really well. So basically, when they get the list of the policies, so it's okay. But still, I think you are right. It's still a little far away from the human-based coding, right?
Because as far as I know, is that different ARM training model have different training data, and the training data is different that will impact your classification performance. So if you edit the prompt, or if you are a transportation expertise, do you think that is workflow for shrinking the state training set?
Yeah, it actually worked. So even for the few shots, we have several instructions for them. For example, what we want in terms of the intermediate level of the policy, we might give an example of that. And the few shots, we just human code everything and give them the examples. Actually, ChatGPT learned okay, but we will just figure out what are the exact differences among those different methods. Yeah, thank you.
Great. To ensure we all have time for lunch, we probably have to move to the next presenter. Thank you. Alexander Ryan from University of Arizona. Next one.
Hello, just to introduce myself, my name is Alexander Ryan. I am a Master's of Urban Planning student at the University of Arizona. So coming into this, generative AI was a very new topic for me. So it was a really exciting opportunity to learn something new. So I'll be presenting using LLMs to write a heat action plan, successes and opportunities. So it should be no surprise that the use of large language models, or LLMs, have become increasingly popular in recent years. The figure on the right shows that the trend of papers containing keywords like large language models has increased over 650% between 2018 and 2024. It's also been used in the plan development field, with the recent Plan Tucson update using AI to analyze large volume of public participation data, as well as to develop communication tools. And in the field of plan evaluation, it's been found that the use of multi-agent LLMs consistently surpass the plan evaluation agreement threshold. One of the main methodologies that I've worked with my research team that focuses on heat resiliency and plan evaluation is the plan quality evaluation for heat resilience. It expands on existing plan evaluation methodologies that use standard plan content analysis, and it evaluates plans for 7 key principles: goals, fact-based strategies, implementation and monitoring, coordination, public participation, and uncertainty. For this project, we'll be focusing mainly just on the fact-based and strategies, as that's the main content within these plans. And there's 2 steps to this. There's the quality principles evaluation, which evaluates the inclusion of 56 criteria across those 7 principles, and the heat strategies evaluation that evaluates the inclusion of 27 different strategies across 8 categories, 4 of which are for heat management, and the other 4 are for heat mitigation. And you can see all those strategies in the figure on the, I guess it would be my left. You're right. And then there's a binary scoring system used for this, where a +1 is given for included policies, +0 if not, and then for the heat strategies, an additional +1 is given to those that are heat specific. So the preparation of these hazard-specific plans is really complex, data-driven, and contextually specific, and it's aimed to prevent losses to people, habitats, and places. And with advancements in computational capacities and access to LLMs trained on granular climate data, the question of whether or not planners can integrate this into their work remains. For this project, I'll be primarily focusing on how climate LLM-generated fact-based and climate LLM-generated strategies compare to those in original plans, and we'll be focusing specifically on Tucson, Arizona. The 2 LLMs used for this were Chat Climate and Climate GPT. Chat Climate is developed by researchers in Switzerland and Germany, and it's an AI chatbot that's fueled primarily and trained on Intergovernmental Panel on Climate Change, or IPCC, reports. Climate GPT is based in Amsterdam and also uses IPCC reports, but goes a little bit deeper using .gov websites, published papers, expert interviews, public IFT data, among others. And for the heat action plan, we'll be focusing on the City of Tucson's heat action roadmap from 2024. This is an award-winning plan, and it's a great example of a high-quality technical plan that's based in climate science and community participation. And like this plan, we want to make sure that the LLM-generated responses are hazard-specific, focused on heat, context-specific, using place-based knowledge, and reflecting planning best practices. That is, it understands the nuance in planning, but it also is, the outputs are in generally accessible language. A lot with these climate reports is that they are really heavily reliant on scientific jargon, and these heat plans or any general plan for a community has to be written in very accessible language for the general public. So for our methodology, we started with identifying 6 prompts. We wanted to keep this to a limited number in order to reduce any potential environmental strain that these LLMs have. For the fact-based, the first 3, we started with creating a sample plan introduction that outlines the threat heat poses to Tucson. The second one looks at how the threat of heat in Tucson compares to other major US cities. And the third looks at identifying vulnerable populations to heat within Tucson. For the strategy prompts, we use the same prompt just switched out the strategy category between mitigation, management, and governance. And once those prompts are fed into the LLMs, we evaluated on their response quality metrics that I mentioned earlier, making sure that they're hazard specific, context specific, and reflecting planning values. We then also evaluated the LLMs on their inclusion of different metrics within the plan quality evaluation. For the heat action roadmap, we started by coding with the plan quality evaluation, then moved to the response quality metrics, and then we compared the heat action plan and the LLM responses. For the fact-based, you can see the LLM on the left and the heat action roadmap on the right. I also included a QR code if you're interested in reading the full LLM responses. For the first prompt, when asked about a sample plan introduction, Chat Climate really struggled with this. It generalized the threat of heat at a national context. It wasn't able to give any specifics about how heat was specifically affecting Tucson. Additionally, it used really heavy scientific jargon that wouldn't be commonly found in these planning documents. For Climate GPT, on the other hand, it gave a really detailed response, and it correctly identified certain environmental and urban design characteristics that made heat more significant in Tucson. It also included the purpose of a heat action plan, which is a really important metric that's looked for in the goals section of the plan quality evaluation. For the second prompt, when asked about comparing heat to other major US cities, Chat Climate again struggled with this and generalized the threat of heat to all of North America, rather than specifically focusing on Tucson. Whereas Climate GPT was able to compare the heat not only to cities with similar environmental characteristics or population, but also to other major cities within the US. And for example, comparing how the heat in Tucson is different to the heat that's experienced in a major city like New York City. For the third prompt, Chat Climate hallucinated and was unable to identify any specific populations within Tucson that were more vulnerable than others to heat. While Climate GPT excelled in this one, it was able to correctly identify that there were more vulnerable populations living in South and East Tucson, citing that there were increased outdoor workers, age demographics, and limited access to cooling centers. It also incorrectly identified the University of Arizona campus as a more vulnerable area, citing that many students were outdoor workers, which isn't entirely true. So for the heat action roadmap, you can see that all but one of the plan quality metrics were met. The only one missing was the mapping of projected heat. And of those that were included, they all scored maximum points using on the response metrics. For the strategies, this is where the LLMs really struggled. They weren't able to differentiate between mitigation, management, and governance strategies. Additionally, some of the strategies proposed weren't very context appropriate. For example, Chat Climate suggested pavement watering as a solution to reduce local temperatures. But for an area like Tucson that has really limited access to water, this isn't likely a solution that would be seen. For the heat action roadmap, you can see that they have a much more diverse range. And I do want to apologize, I think some of them missed out when the font size changed maybe with the PDF, but the three that were missing were park and trail operations, vegetated parks and open space, and water features. And as I mentioned earlier, something like water features might not be the most appropriate strategy for an area like Tucson. And of the strategies they included, they scored relatively high with the response qualities, with all of them including really detailed implementation tables that outlined funding, timelines, and implementation partners that gave real strength to these strategies that the LLM-generated responses lacked in. When we compare the two, you can see that the heat action roadmap outscored on nearly every metric, both in the fact-based and the strategies. For the fact-based, Climate GPT was the best of the LLMs, with Chat Climate really struggling to specify the threat of heat to Tucson, but there were still limitations, mainly with the mapping of existing and projected heat due to mapping limitations with the LLMs that we used. For the strategies, you can also see that the heat action roadmap had a much more diverse range of policies and indicates a more coordinated approach across citywide to have a more diverse range of policies. Whereas nearly every Climate GPT generated strategy also was generated by Chat Climate, indicating that they're likely pulling from the same limited select sources. So overall, I believe that these LMs really struggled to capture the complexity that's required for these hazard-specific plans. While the fact-based were more aligned with real-world plans, the LM strategies really tended to fall short on this. Additionally, the strategies tended to be really small-scale solutions rather than large-scale. For example, there was a lot of strategies that suggested cool roofs, but very few looked at urban development patterns or land use as a contributing factor towards heat. With that said, I do think there's a couple of best use cases for LLM use in plan generation. I think for potentially resource-strapped communities that might lack the funding and or climate expertise to develop these specific hazard plans would be a really interesting case, as well as the use of LLMs to conduct preliminary checks for internal consistency throughout a network of plans. That is ensuring that the goals all align with each other throughout the hazard plans, transportation plans, comprehensive plans, etc. These LMs could also really be improved by being trained on a network of plans that would hopefully not only increase the place-specific knowledge for these LLMs, but also allow for more consistent planning language rather than heavy scientific jargon that's more commonly found in climate reports. In the future, I think it would be interesting to explore how LLM use in other plan components, for example, implementation and monitoring, or internal consistency, or even public participation, as it was mentioned earlier. And I also believe it's really important to emphasize the need to explore the ethical and environmental concerns related to AI use and LLM use in urban planning as such a people-oriented field. Thank you.
So, any question from online audience?
I have a question. Can you hear me?
Just a second. Please go ahead.
Okay, so two things. I really like this presentation. I would suggest you look at the work of Hamish van der Ven, who is at the University of British Columbia, and he wrote an important piece in Environmental Research Letters that talked about how LLMs tend to crop recommendations, more radical recommendations. So you may be getting very bland recommendations because of the deeply embedded biases in LLMs. And second of all, could you talk a little bit more about how you'd envision civic participation, even though it was outside your scope? Because I think it would be really hard to engage the local public about these recommendations or the problems.
Yeah, first of all, I really want to thank you for that recommendation. If you could type that in chat for me so that I could write that down, that'd be really helpful, and I'm interested in exploring that. In terms of the public participation piece, I don't know if I can top the earlier presentation about that community tool. I think that was a really interesting use case for how public participation could use generative AI. But I also think it's about finding the right balance. I don't think the solution is necessarily just going to be have the public use generative AI and that's how we figure out what we put in our plans. I think it's finding the most appropriate use cases and finding that appropriate balance. Like the Plan Tucson update, the use for AI focused on public participation, but it was mainly just to summarize and to generate communication tools. So I think it's about finding the right balance. And I agree that public participation should always be people-oriented first, and not all these solutions might be applicable to the field.
Okay, how about online, in person? Yeah, sorry, go ahead.
Oh, is there somebody online?
No, sorry, in person.
Yeah, no, I just want to build on that because I was thinking along the lines of the public participation stuff and like that the way, like, say that essentially we're trying to see if these tools can help us come up with plans. But when we make plans, and especially when we're coming up with strategies, right? Where there has to be like a buy-in, if you will, or an engagement and inclusion of people in the development of those strategies so that they're innovative, relevant, equitable, etc. Doing this with technology prevents that from happening. And so I think that that's more perhaps where that question was going, and I was wondering if you, it's not, I don't, my question at least, is not so much about like the balance of these tools, and so therefore now we can use this other tool to do public participation. It's more about like this inherent barrier to participation by relying on technology to do things for us. So that's, I think that's where, at least my question.
Yeah, I think that's a really great question. And yeah, I think I might need some time to think about that, but
That's okay, it's a tough question, so just don't.
all right. I'll think about it and I'll get back to you at lunch.
Yeah.
She's just plugging her.
Come back.
Yeah, thank you, great research. I don't know much about the future TVs we have used. I'm thinking, are they really LLMs or they are small language models because they'll be taught on a specific data set? So it would be really interesting in terms of next step to really compare this against a larger, the real LLM that may take into consideration the geographical things that you're being really so now. So that can be a next step.
Yeah, that actually is one of the next steps that I have planned for this. I plan to incorporate a more broadly accessible LM like ChatGPT, and I want to see how that might compare with LMs that are really focused on this granular climate data as opposed to just kind of generalized knowledge. So I appreciate that. Thank you.
We still have one question. Lady in the back.
I had the same.
Oh, I see.
They've done it.
All right, thank you. So our final presenter in this session is Dr. Li Ying from University of Buffalo, and she will present online. Li, I stopped sharing now, and can you share screen?
Oops. Can you see my slide? But looks like it's the wrong one. Let me switch that.
Yeah, we can see it.
What's wrong? Can you see my slide? Okay. Hi, everyone. Seems that today is the day of how we use AI. This morning, when I opened my New York Times email, the headline read, "How Trump Uses AI." Honestly, I'm not sure that I would dive into that article, but I'm absolutely interested in all of the amazing presentations and discussions that we have so far. To wrap up this morning's session, I will add my own piece of using ChatGPT to conduct content analysis on qualitative data, specifically Twitter data. Now you might notice that my title, the second half of my title didn't make it into the program, but that's okay. It just makes my presentation sound a little more mysterious. For Twitter data analysis over the last decade, we have seen many studies used natural language processing to track topics and also classify sentiments, typically as positive, negative, or neutral. While useful for many contexts, this approach falls short in cases like ours, to study Twitter narratives after tragic, racially motivated mass shooting. Because simple sentiment analysis is almost meaningless in our case. As you can imagine that most of the reactions will be negative. So it adds very little value to the literature. Similarly, identifying just trending topics alone doesn't really help to reveal the deeper concerns and priorities of affected communities, as we find in our recent published paper. But the LLMs, it helped to open a door to a different perspective, one that is more cost efficient and capable of deeper analysis beyond surface level sentiment or simple topic extractions. So in this work, we use ChatGPT to help us dive into Twitter narratives, connecting emotions to proposed actions, uncovering the underlying themes driving discourse, and help us to explore how these discussions reveal community concerns and inform transformation after tragedy. Our team includes one doctoral student, Zhao Dai, and several professors from University of Buffalo and China University of Geosciences. So this shooting, how the shooting occurred, I don't know if you can see this map of Buffalo, and in the middle, this is Main Street. So on one side of Buffalo where the shooting occurred, it's most Black, over 90%. And on the other side, it's dominantly white. So this city is divided. The shooter's goal, as you can see here, is to kill as many Blacks as possible. And he went into the only full service grocery store in this Black community to kill Blacks. And up here, it's our recently published paper, which I just mentioned, also by the same group. Even though here we said ChatGPT, but we actually focused on using LDA for topic modeling. So I'm going to promote this paper a little bit here. I hope you can check it out, and if possible, please cite it. We find that in this paper that social media discussion shifted quickly from local and community-based discussions to more broader and general discussions like shooter's identity. So for this study, we wanted to focus on digital civic participation and ask, can social media platforms serve as tools for advancing civic engagement and supporting community mobilization and transformation after such tragedies? How do online discussions reflect community priorities and emotional responses? So immediately after the shooting, there were many news reports and promises from various levels of government to invest in these underdeveloped communities and drive change. Yet, a year later, you see this kind of reports continued, but the local residents, they felt abandoned. And one of my co-authors, Henry Taylor, he shared at a community meeting that 90 to 95% of the fund never stayed in the community. They were redirected elsewhere. So our goal was to understand perspectives from the ground up. What do people think about the shooting in the community and its transformation? Rather than simply evaluating sentiments or identifying topics using models like LDA, we focused on three interrelated dimensions. Public sentiments about emotional reactions and resolutions. So these are about what actionable steps or strategies emerge from these discussions and underlying topics driving the discourse. So thank you, Alex, for also sharing with us about your results from literature review on multi-layer or multi-level analysis. We're not there yet, so much yet in the literature. So we begin with sentiment analysis and then transitioned into resolutions and finally identify themes behind both. This help us to answer critical questions like how do emotional reactions suggest engagement? What strategies emerge from these discussions? How can these insights inform community transformation and policy responses? So we have like 3 dimensions here in our analysis flow. After retrieving and cleaning tweets, we begin with multi-level sentiment analysis, building on our earlier work to capture mixed feelings because people can feel both angry and still hopeful. Next, we link the sentiments with resolutions, connecting emotional reactions to actionable steps. In total, we identified 7 categories of sentiments and 4 categories of resolution types. And during this process, we have the human evaluation involved, as other presenters mentioned. This is very important, and as many of you have known that even with the same input, ChatGPT can provide different answers. So we run consistency tests many times, and after that, we ask ChatGPT to help identify sentiments and resolution and the topics. So in terms of the topics, for the reason to identify these topics or reasons is to understand, for example, why people feel angry or frustrated and what they were advocating for. Okay, and let's see some results. These are results from consistency tests we ran many times, and on the right upper corner here, this is one from earlier tests, and as you can see, there are a lot of like variabilities, kind of, the results shifted between different categories. And then on the left bottom corner here, it's the results after we provide clear categories with clear definitions for every category. There are still kind of variabilities here, but it looks more stable. So overall, we think that the results were reasonably stable. And then we move to the next step. So this is the result from our multi-level sentiment analysis, and it's built upon our earlier work published last year. So the first row has the primary emotion, and then the second emotion is in the second row. So in this case, as you can expect, that people feel mostly, sad and angry, and they are actually mixed. So they feel sad and angry, and the second one is they feel angry and also sad. But then they can be mixed with other type of feelings also. Next, we linked sentiments with resolutions, connecting emotions on the left side to resolutions on the right side. So here, if you look at the resolutions, advocacy was the most frequent resolution, followed by no resolution. And advocacy is primarily linked to anger and frustration. If we look at frustration here on the left side, half of the posts expressing frustration offered no actionable steps, suggesting that some people felt frustrated without saying any actionable steps or became disengaged. Sadness is most often connected to solidarity, and fear is connected to advocacy. Because of the time limit and also because we limited number of slides, I don't have all of the results on resolution topics and sentiment topics displayed here. The first one on the left, it shows advocacy and the things behind it. So it's tied to things like gun control, racial justice, systemic change, and societal change. And for solidarity, it tied to mostly community level actions like a shared grave, collective mourning, and community unity. And there is also disengagement, which I don't have it here, but when it appeared as a resolution, it was largely tied to emotional withdrawal and a sense of irrelevance and hopelessness. So some takeaway, by linking emotions to actions, ChatGPT help us to uncover how emotional reactions translate into civic strategies and identify gaps in engagement. And in recognizing these gaps can help community leaders and policymakers target support where it's most needed. Themes like racial justice and community unity reflect grassroots concerns that might otherwise be overshadowed by more general or broader national debates. By using ChatGPT, we processed large-scale data, in our case, over 50,000 tweets to capture complex emotional patterns and community-level ideas, while acknowledging the need for human evaluation throughout. So we went back and forth many times to discuss and evaluate results from ChatGPT. So our study results demonstrate ChatGPT is a useful tool, and social media platforms can serve as tools for civic engagement. I'm not quite sure what the time looks like, but I'm going to stop here. Thank you.
Thank you, Lee. Yeah, I think good timing, and probably you can take one more question. Oh, online, let me see with question. Oh, no, not here.
I have a question, but you can skip me if there's somebody in the
Oh,
audience.
we don't have people on site have question for now. Probably yeah. Please go ahead.
We know that digital participation is radically different from in-person participation, which is unsurprising why anger showed up so clearly, although the way you used it with these multiple sentiments, I think is really helpful. But have you ever thought about testing this against in-person participation to see what sentiments appear?
Well, that's an interesting question. Yeah, I kind of thought about this when I was listening to other presenters. So for us, it's mostly, analyzing tweets and then had discussions about whether we agree with that evaluation or not. But we're not there yet to think about, the next step, maybe to actually ask people about that, to go into the community, the local community, and ask them about that specifically. So that's, thank you for that comment.
All right, so I think that's it for our morning session, and one more applause for all the presenters. And yeah, we will come back at 1 p.m.